Hey everybody, you guys able to hear me okay? Great, thanks. Okay, we will go ahead and get started then. Alright, so start with course logistics. We've got quite a few things to talk about today. So first up is your full design revision 1 for your projects. That's going to be due Sunday by midnight. So it was originally slated to be due on Thursday this week, but I feel like it probably would be better if we had a little more time on that. So we'll have that due on Sunday by midnight. So let's talk a little bit about that specifically. So for this checkpoint, you're going to submit kind of your first full revision of your prototype, and along with the revision of your prototype, you're going to submit a little bit of supporting documentation to help somebody else in the class review it. So essentially what you're going to be doing is, taking the prototype you have now and making progress on it, and then also thinking about what someone would need to know if they didn't know anything about your project and they were going to evaluate your prototype or try it out. So that's the supporting documentation that you'll need to include with this. So this prototype will be, we're going to say, like roughly medium fidelity. It doesn't have to be super high fidelity, but it should be a little bit better than what you did last time. You should continue to make progress on that. And the way we'll do this is everybody will turn in their prototypes, and then the prototypes will be randomly assigned to people in the class to do a short peer review. So the minimum requirements for what you turn in, it needs to be a broad prototype that represents all of the functionality in your product. It needs to demonstrate progress since the last checkpoint, so it needs to show that you've done work since the last time you submitted the prototype. It needs to have the majority of its interactive elements working, and I know that we have some constraints with the prototyping software, and we're still working through that, and we'll talk more about that. So in general, basic navigation between screens or pages should work, but you can put placeholder elements in for anything that you're still working on or that you aren't able to do in the prototyping tool yet, and that's fine for this checkpoint. The other big thing is that you need to turn in a document with supplementary information that describes how your prototype should work. So this is for the person who's going to evaluate your prototype. So it should include how to open it up, any information about maybe just a brief summary of what your app does if it's not self-explanatory, and then notes about any of the limitations of your prototype. So let them know what's missing, what's incomplete, and you can do that in the supporting documentation, and also within your prototype. If something doesn't work, you can note that within the prototype itself too. You may also want to include just a video walkthrough of how to use your prototype, and you can just do a screen recording showing going through it, whatever you want to do. That may make it easier for the person doing the peer review. So the main goal is to demonstrate that you've got a comprehensive interactive prototype that when you combine it with some extra documentation, that somebody else in the class can attempt to use it and understand it and give you feedback on it. So we're really aiming to give each other feedback about our designs, about our prototypes. So for the peer review, so everybody who submits a prototype will get somebody else's prototype to review. So you'll receive so the initial prototypes are due on Sunday. Then on Tuesday, everyone will get a prototype to review, and that'll be due back by Thursday. And as far as what the review is, it's going to involve just answering some basic questions about, how well you were able to understand what the prototype does, what problem it solves, how usable it is, and then you'll have an opportunity to give some detailed feedback, about different aspects of the prototype if you'd like. I'll, set up a survey so you can just type all of this in, and the actual peer review should not take that long to actually do, because it will mostly just be answering survey questions, but then there will be some opportunity to provide feedback. And I would encourage you to provide as much feedback as you can. It will be helpful. So in terms of grading on this checkpoint, everything will be evaluated on how well it meets the requirements of this checkpoint, meaning you've got to show progress from last time, you've got to have most of your interactive stuff there. You can have some placeholder things and some things that you haven't figured out yet, that's fine. The peer reviews will not directly affect your score. Those are just about feedback, just to help you and to help me as I check everything off. So the main thing that's pretty important here is, because we're doing this peer review thing, we can't have any late submissions because everything needs to be in so that it can be assigned out to be peer reviewed. So keep that in mind for this checkpoint. You don't want to submit late on this. And then as far as you submitting a peer review, you need to submit that. If you don't do your assigned peer review, then you can only get up to 50% of this checkpoint. So it's also important that you do your peer review on time so that we can get feedback to everybody. So in terms of the exact requirements for the submission, this is what you should submit to Canvas. First of all the files to run your prototype. I know a lot of you have included like the live links to go to in the browser. That's fine, but if your software allows you to save a file version of your prototype, so in Figma it's a .fig file, in XD it's a .xd file, please include that in the submission. That helps me keep track of where things are in time and your progress over time. If you have software that doesn't let you save one of those files, which I know there are a couple of them, submit a screen recording of your prototype, just walking through it, using it. I mean, also submit the link for me to use it and for the peer review to use it. But if you can just do a quick screen recording of going through the prototype, you don't need any audio or anything, just going through the screen, showing that it's interactive. Please do that too. I'd encourage everybody to do that, but if you don't have a file that you can submit, you need the screen recording, just so we have a snapshot of it in time. So in addition to your prototype, you should submit a PDF, and it should explain what your product is, any instructions on how to access it. For most of you, that will be visit this URL, and then any limitations, about the prototype, or any special instructions that you want to point out to the person reviewing it or to me, include that in that PDF. If you're a team, you also need to include a document that just gives a couple sentences stating each person's contribution to this phase of the prototype. And I think most of you did that last time. And so that's the only additional thing for teams. For teams, you all do need to submit, make a submission. I realize it will be the same files for everyone. That's fine. It just helps things work well on Canvas. All right, so are there questions about this checkpoint? So I think everyone should have feedback on their prototypes. There were a couple that I had trouble accessing, so I probably posted a comment on yours if it was giving me an error. There are some weird things that can happen with Adobe XD, and sometimes the XD file it shares is not what you actually want. So if I left a note on yours, please just resubmit your file or resubmit a link. But everyone should have feedback apart from that. Okay. If you guys have questions as we go, just let me know. We'll move on to, we have assignment 3 is posted now, and that will be due a week from today. And it is actually a pretty easy assignment, and I think it's pretty enjoyable. So let me just jump through it real quick. So what you're going to do is you're going to find a set of human interface guidelines. And so these are kind of just design standards or rules that different companies or organizations have established for working with their platforms. So I've given you some examples here. I've just listed Apple, Android, Microsoft, and then the United States Web Design System. There are a bunch of others out there. So what you're going to do for this is you're going to find a set of interface guidelines, and you can use the ones listed above if you want, but I'd encourage you to go out and find one that's interesting to you. Certainly lots of companies have them, lots of platforms have them. Find one of those, spend about 10 minutes or more kind of looking through it and reading it. Then for the assignment, all you need to do is, first of all, say what set of guidelines you looked at, provide a link to those guidelines. Then just a couple sentences describing, what's covered by the guidelines. Is it, all of Apple's products, or is it, Microsoft's cross-platform standards? So just a little bit of information like that. And then the third thing you need to include is just at least one interesting or non-obvious example of design guidance that you encountered while you were reading the guidelines. So just something that maybe you didn't think of before, or you just find interesting, or if you find something that seems counterintuitive, that works as well. So just to show you, here are some of these that I have as an example on the assignment. This is Apple's Human Interface Guidelines. So they've got it divided, watchOS, tvOS. You can click into it. There's kind of this different guidance about visual design, branding, app architecture, stuff like that. Similar with Android, all of these standards or best practices that have been established for the platform. Here's Microsoft's Fluent Design, which they've got some cross-platform stuff. And then here's the US Web Design System. So this is kind of standard for government websites designed in the US. So you can go through, design principles, stuff like that. You'll see a lot of stuff that we've touched on in class probably. Components, all kinds of good stuff in these. So that's assignment 3, and that's due a week from today. And just submit it through Canvas. You just submit a PDF or whatever file type works best for you. Are there any questions about assignment 3? Okay, let me know if you have them. Okay, so other news. I am going to dedicate a lecture on Tuesday the 13th, so a week from today, to doing hands-on work with prototyping tools. So I'm covering, I plan to cover Figma and Adobe XD primarily. I'll cover a lot of basic and some advanced stuff on those and talk about some of the things that are difficult to do in each of them, kind of the limits and where all of that falls and what you can do to try to improve things. But if you have specific questions, which I've got, a lot of your comments from when you did the reflection about the prototyping tools. But if you have specific questions related to building your project in the prototyping tools, I've put a ungraded survey on Canvas, and if you could just put your questions in there, all of them, and that way submit that by Thursday this week, and I can be sure that I am ready to address all of the questions that you might have. Like I said, I'll definitely come with just kind of a default set of explaining things, and I'll be happy to take questions while we're talking about it too. But if there are specific things that are problematic or that you'd like to know more about, if you can let me know through this survey ahead of time, I can better guarantee that I'll get you a good answer, and that we can work through it during that lecture. So, in related news, the mid-semester survey that was up last week, about 21 people responded, so I thought I'd share the results with you. And this is kind of relevant to today's lecture because we're going to be talking about evaluation and analyzing results. So first question of overall experience in the course so far. Looks like we're doing okay-ish, mostly on the upper end here. Looking at the specific areas, was broken down into lecture assignments, kind of all of these things. You can see that for the most part, kind of sticking in the 4 to 5 region. Everything's averaging a 4, within the 4 range. And you can see a couple of these. You can kind of see where some of them have a few responses saying not so good, and then the majority of the responses sitting at the 4 or 5 region, which is good, but we definitely want to try to improve where we can. So I looked at your feedback on each part of this, and kind of categorized it, and counted up the areas that were most frequent. So I should say, first I should say thank you for those of you who gave feedback. It is really helpful because I do try to adapt the course as much as possible to work for you. So the worst part of the course, the most frequent response here was that there are too many or too frequent assignments. And some of those were just kind of general about too many assignments, and some were specific about the timing of the due dates. The other most common worst parts of the course, meeting online, was not popular. It's just not surprising. There were a few different things about the project that people were concerned about, and then one about the exam questions specifically. So, and we're going to try to address these a little bit to the best of our ability. So let me go through a few more of these responses. So best parts of the course, project kind of topped that. People like learning new things, that's good. Some people like these lectures, good deal. Content, low stress exams. Shout out to the one person who said, good instructor. It is anonymous, so I don't know who you are, but thank you. Anyways, so a lot of good things about the course, which is good. So changes. This is one of my favorite areas to look at is kind of what would you change to make the course more enjoyable and useful. And this tracks with the worst part of the course. So less frequent assignments is kind of the change people would make. People also would like to meet in person. Peer feedback on projects, good news there, because that's about to happen. More time teaching about the projects, more design-based assignments, different prereqs. That's an interesting one. So it is kind of an interesting balance, because there aren't any like prereqs in terms of programming or anything. So I definitely know that people sometimes do feel a little thrown in the deep end, especially with the project. But hang in there, and if you're worried, let me know. I'm always happy to meet and help in any way I can, especially if you're feeling overwhelmed. But to try to make it so that there's not really any specific set of knowledge needed for the course. Okay, let's jump to what would you like to spend more time on in the rest of the semester? So prototyping was popular, interface design kind of goes hand in hand with that. App creation was mentioned. We will spend more time on all of those things. So we will specifically have a strong focus on prototyping coming up with our prototyping tools. I'll work app creation into the course probably a little bit later, just talking about how kind of the basics of making an actual app, like a mobile app, and on the different platforms. There were some specific areas of interest. I will add anything that I don't already have on the list to the list, and we will be sure to cover each of them a little bit before we're done. And then in terms of general comments that people provided, a lot of general praise or positivity for the class. One last plea to reduce the amount of homework, and one request to wear Halloween costumes. So overall, I think pretty good. So thank you for your responses there. So let's talk about what we're going to do to try to address some of those. So in terms of the course content and trying to, maybe we're going to focus a little more on things that will help you on your project, practical things, so using the design tools, prototyping stuff, and then of course any of the topics that you mentioned specifically that you have an interest in, I've added those to kind of the appropriate lecture slot to make sure that I get some content on those things in there. So let's talk about the big one, kind of the course workload. And so kind of, I do have to admit to you that HCI is a different kind of course in terms of if you've been taking a lot of engineering courses or not doing really any upper level social sciences. It is quite overwhelming at times. I don't know if this will make you feel better or worse, but if you were to go out and look at other universities and kind of their HCI courses, you'd find a similar workload, I guess, style of workload. And I think kind of there's a sense that there's a lot of little things that are due frequently. And there's also quite a bit of reading and writing compared to other non-social science classes. So what I can do to try to help you manage this, I know that the due date scheduling can become overwhelming. So believe it or not, I do actually stagger things kind of as best I can to limit the impact on you. But I'm going to see what I can do in terms of kind of maybe broadening some of those due dates, giving you more opportunities to decide when to turn things in. So in general, I can I can assign things sooner and give you a bigger window, but that tends to not really change anything. We're really good at waiting for the deadlines. But that said, I'm taking it into consideration even more now as I schedule things. I'm going to try to start opening the quizzes up for longer periods of time, so that nobody misses the window to submit those, and hopefully that will be helpful. Also, you will be glad to know we won't have a reflection for I think the next 2 weeks, because you've got kind of this project deadline, and then a week after that we'll have an exam assigned during that period, the second exam. So we will do our best to schedule things. If you've got a situation where you're overwhelmed and you've got just circumstances where maybe you've got a lot of other classes or things are just not lining up for you, please talk to me. I'm happy to work with you and be flexible as much as I can. Certainly not trying to impact your grade negatively with the scheduling of things. So just want to reassure you there. Okay, and last thing, course logistics. So if everything continues how it is, we will offer, I'll broadcast class from the classroom. There's a question. Is the second exam, is it a final exam? So there are 2 more exams. There's 3 exams in total, and you've done 1. There's a second one and a third one, but the third one's not cumulative or anything. It stands on its own. So they're all kind of independent of each other. The last one's not any bigger or worse. But course logistics-wise, hopefully next week we will be able to host class in the classroom for anybody who wants to come attend it there. We'll also put it out on WebEx. I will confirm that for you on Thursday. Okay, question. Do we have a final or just the 3 exams? Just the 3 exams. There's no final in this class. So it's just the 3 exams and your project. That's the major part of your grade. Yeah. Okay. All right. So last time we talked about designing and conducting user studies, part 2. And specifically, we talked about building an evaluation or a study. And we talked about, figuring out what kind of questions to ask, what kind of questions need to be answered, identifying variables, creating protocols, everything like that. We've emphasized the difference between user studies and user evaluations, where one is more controlled than the other, and they kind of have different purposes. Talked about that a couple of times. We talked about different types of measures, so self-report being things that a person, evaluating your interface or participating in your study reports about their experience directly. Behavioral being a little bit more objective, being something that we can observe or record and analyze later. And physiological being direct responses from a person that are measured. Talked about experimental design types, so between subjects and within subjects. Between subjects being that graphic we looked at in the beginning. Between subjects meaning each participant only sees one version or one condition. Within subjects meaning each participant sees every version of the things that you're evaluating. So they're doing the comparison themselves. So today we're going to talk about analyzing data, and kind of get started. We'll talk a little bit about the reflection that you just did about participant response bias. So I've read through the discussion post this morning, and you guys had some really good insights kind of from this paper. So this is an older HCI paper. I think it was published at the CHI conference in like 2012, and it was a study about what's the response bias caused by a particular interviewer / researcher and a particular set of participants. And kind of the main finding, of course, being that you could influence the participant response just through kind of the interviewer characteristics or things that the person perceived about the interviewer. In particular, we've talked about some different types of biases, but there are several biases that come up when you design a study or an evaluation. And so in this case, we were kind of looking at social status and maybe a social power construct, and looking at demand characteristics. So the idea that the participant, the person evaluating the interface or the product, was able to maybe understand, or they had a perception about what the researcher, what kind of result they would want. So the paper had a few hypotheses about what would happen, and they all, for the most part, I think all of them were fully were not rejected. They all checked out. So just to kind of look at some of the graphs from the paper. So they did 2 experiments, and they were basically comparing. They were just showing the same. In the first set of studies, they were showing the same video on 2 different phones, and having their interviewer either say that they were part of the design process or not, if they had a stake in it. And so, just looking at that first part of the study, you could see that there was an effect where people would tend to prefer the interviewers, even though they were the same. And then we also broke this down in terms of looking at a foreign interviewer versus a local interviewer, where the study was conducted, and then looking at university students among compared to rickshaw drivers in the location that they were testing this, and found some great some interesting differences that would affect the evaluation of the technology, and that's kind of the main I guess point of this finding, is that though we didn't see this effect hold as much with the university students, we did see it hold with the rickshaw drivers. And see, this is just a graphic showing the 2. So even to the point of where we could show a degraded version of the video and get people to choose to prefer the visually degraded version in comparison to the high quality version, based on these response bias characteristics. Up here, and so here's just another glimpse at that, and kind of the findings there. So, looking at it, the main takeaways are kind of, how do you, first of all, I guess this paper was kind of influential in terms of, it was one of the first verifications of this this particular kind of bias within technology development, which poses a real problem. And so, of course, the implications are you need to find ways to kind of deal with this bias. But the main reason that I thought this was a good paper for reflection was to kind of show you that there are a lot of factors that exist outside of the thing that you're testing, and if you don't isolate them well or pay attention well enough, other things can get put into your measurement. Now here, obviously they were trying to do that, but it demonstrates that there could be problems with other studies that you might not catch if this wasn't what you were looking for. So I think there were a lot of good points that were pointed out in your reflections, specifically like looking at being familiar with technology. So like if you were to run the study again today, 8 years later, right? Would you get the same results? Was it maybe that one group was less familiar with the technology, and so maybe they were just kind of more attentive to what they thought the researcher wanted them to do? Another interesting point, somebody mentioned trying the experiment with children, and I think that would be really interesting, because even in their biases, sometimes children perceive what the researcher or what the experimenter wants differently than adults. So that could help lend some insight into something like this. A lot of people were saying it would be interesting to look at doing this in different cultures, with different interviewers and with different technology, right? So obviously you can think about how these combinations would multiply, and in the paper they talked a little bit about some of the findings from other cultures in other studies that were looking at cultural effects, and how you might expect some of that to differ. So I think I have a note here. So interestingly, they had this category of where they could choose that the two videos they were comparing were the same rather than choosing one or the other. And that's kind of important for us today when we're talking about evaluation. And you'll notice that the authors of the paper said, well, we'll just set that same data to the side and analyze it later. I don't know if they ever did. I'll have to look and see if they did a follow-up on it. I would guess they didn't. So when you do that kind of thing where you're choosing between two and then you have a same or a neutral option, sometimes that can really make things difficult for you if people stick to that middle ground too much. But it's kind of a design decision in terms of, is that merited? Like, is there a legitimate middle ground? And we'll talk about that a little bit today with data analysis and survey design. But I hope that you enjoyed that paper. It definitely gives you a glimpse, although it's pretty old, 8 years ago, into kind of some of the factors that you have to deal with when you start to evaluate things. So with that, let's jump into evaluating or analyzing the data for our evaluations. So as always, we should remember kind of our goal in usability testing or user studies. We're trying to either get feedback or evaluate some part of the system or compare design alternatives. And we've talked about different measures. A lot of what I'll talk about today, there's this book, Measuring the User Experience, is pretty good in terms of talking about a lot of different types of measures that are available for different interfaces, different scales. So I've pulled a few examples from there as we go today, and we'll talk about these. And we've talked about kind of these measures in general last time, the different types of quantitative and qualitative data, but we'll talk about how to analyze them. So today we'll also spend some time discussing just some basic statistics. So this HCI, Intro to HCI course is kind of just a mixed bag of everything. So you get a little bit of psychology, a little bit of computer science, a little bit of design. Here you'll get a little bit of kind of just inferential statistics that are pretty essential for when you measure things and actually doing things with the data that you gather while you measure things. So I've got this picture of this book here. It's called Discovering Statistics Using R. There's a version called Discovering Statistics Using SPSS. So R is a statistical programming language, we'll call it. But it's kind of a whole ecosystem of packages and utilities and just a general programming language that allows you to compute statistics over data sets. It's very popular. It's free and openly available. And so that's what this book is, a book that teaches statistics, specifically, I should say, kind of more social science-oriented stats. So for experimental design and evaluation, which is what we need in a course like the one we have. This book focuses on teaching that, and in this case, this version of it uses the R programming language to do that. There's another version of it that uses SPSS, which is graphical end-user software. It's a statistics package. It's very popular. And I mean, it also allows you to do scripting as well. It's not free, I should say. But usually most universities have a license, and we have a license here if you're interested in using it ever. But the book, there's a version for each. It's a really great book. If you're interested in stats, if you're going to do studies, this is the best stats book that I have read. It's actually engaging and interesting, and has a lot of humor in it. So if you find yourself in need of more stats knowledge, that's a good place to start. So, talking just a little bit about what we'll cover today. We're going to start with descriptive statistics, so just describing sets of data. We'll talk about some of the measures of central tendency, so things like the mean, median, mode of data. Then we'll move into talking about correlations, so how one variable or one measurement might relate to another. And we'll talk a little bit about how that's not always meaningful, but sometimes meaningful. And then we'll kind of finish up with comparing groups, and how do you do kind of a real comparison of groups, whether that be two different versions of a user interface, or two different conditions, or in a study. So I'm going to start by talking a little bit about types of data. So this turns out to be really important for doing evaluation, right? So last time we talked about kind of these different surveys, different things you could measure, right? So you could have, a scale where somebody says, how strongly they agree or disagree. You could have a behavioral measure, like how many errors did they make, how long did it take them to complete this task, that kind of thing. So now we're going to talk a little bit about how we categorize those different types of data for analysis, for statistical analysis. So the first type of data is nominal or categorical data. And this is anything that's an unordered group or category. So some examples I've put here, like if you ask someone which operating system they use the most. They might say, I use a Mac, or I use Linux. And though some of us may think there is an ordering, there is no natural ordering to discrete operating systems, right? They're just categories. Another example is like eye color, right? If we look at discrete eye colors, right? Brown eyes, blue eyes, green eyes, there's no order to that. You're just in one of the categories. So when we have this kind of data, typically we analyze it using just descriptive statistics. So we'll say, this percentage of participants used Windows primarily. You can do a little bit more. You can use it as a covariate in your analysis. So you can start to look at do Windows users more likely to have a tough time with this interface in comparison to Mac users. And so it can serve kind of as an independent variable there. We won't go into the details of that, but so that's kind of nominal or categorical data. So then if we kind of go a step forward, we have what's called ordinal data. And this is basically categorical data, but with some order to it, but not necessarily a meaningful interval between each discrete item. So you can think of like ranking data, like if you ranked your top 100 movies, right, there would be an ordering to it. It has some meaning, that order, you know, which one you like more or less, but it may not necessarily be the case that the difference between your favorite movie and your second favorite movie is the same as the difference between your 31st most favorite and your 32nd most favorite. Those two intervals might be different. So the scale doesn't have meaningful intervals in it. And this is a little bit kind of becomes a big deal and a point of conflict and argument for people. And we'll talk about that. But in terms of if you have just this ordinal data, so just ordered categories, you usually would analyze it in terms of frequencies, like count data or kind of how frequently something occurs within certain groups or conditions. And we'll talk about what statistical tools to use for that. So next we have interval data. So this is data that is continuous. So meaning that you might have like anchor points. So if you look at this example down here on the right, I've got poor and excellent as the anchor points. And then I've got kind of these discrete choices in between. But we're arguing that there are enough points in between that it's a meaningful interval. So you can kind of see where the debate comes in terms of the interval data, versus just the categorical data that has an ordering but no interval. Because how many of these little spaces do you need before it's continuous? And that's kind of a thing that people go back and forth on. So interval data, I should say, also has no natural zero point. So some examples, believe it or not, temperature, kind of like the 0 point we choose for temperature. It depends on first of all, this unit that we're using. But that's mapped, to something that we've chosen. There's no natural 0 point there. The same with a lot of these usability scales that we've discussed. There's no natural zero necessarily in these scales. But the good news about interval data is that it can be analyzed using full inferential statistics. So we can treat things as numbers, and we can do things like add those numbers together and take averages and compare things, and kind of compute probabilities and fit models and lines to things to predict things whenever we have this interval level data. And so of course there's debate about interval versus ordinal and when does it cross over. You see this little snippet that I have on the left here is a version of this scale. One has each bubble labeled, and then one just has fewer bubbles in between the two anchors. And so the question is kind of, where does it make sense to consider it one or the other? And it really depends on the application, and it really depends on how much you want to fight with someone or what the reviewer says. But a lot of times, honestly, at least a lot of the studies that I've done, we end up with this debate about something, and we'll run it both ways to see if it makes a difference. And a lot of times it doesn't. But it's not to say this isn't important, though. Okay, so two more types of data that we need to think about. Ratio data. So this is continuous data with a meaningful area between the intervals, but it also has a meaningful zero value. So things, some examples of this that exist in the world, like your age, your height, your weight, time. So like, time 0 seconds has a a natural meaning to it. It didn't take any time. So these can be analyzed the same way, but they have that nice property of having a natural, meaningful zero. And then we have qualitative data. And so that's data like when you interview someone and say, how did you feel using that operating system, or what are your thoughts about this robot? And then they say a bunch of human words, and you have them recorded and then written down, and then what do you do with them? So to analyze qualitative data, you have to convert it into another form, and we'll talk about that a little bit. Basically, it involves categorizing it in a reliable way, and then usually you take kind of frequencies or patterns within those categories to analyze it. It's kind of labor intensive, but sometimes it is the best source of data that you can get. And I should say that even if you collect qualitative data, which you should always collect a little bit of qualitative data when you're doing something, you don't always have to analyze it. It doesn't have to be your main approach to something. But specifically when you're doing design evaluations, like we do for our projects, or any kind of HCI study, you should always kind of allow people who are evaluating it to give you some just open-ended feedback, because you kind of will be surprised sometimes. You'll get good ideas, or you'll notice things that you didn't think about. Because the other stuff that you measure, you've designed the questions and everything for that, and that limits, right, what they can say. So always good to include an option for that qualitative data. So, okay, let's just imagine that we've, made our prototype, and we're going to evaluate it. Maybe we're just going to use like that system usability survey that's just a scale where people choose 1 through 5 or 1 through 7, how much, how usable it was, how was it easy to complete their task, that kind of thing. Suppose we have our data back, right? And we'll just say it's quantitative data. It's numbers, measurements for different things. The best way to start, I'm going to argue, and I think a lot of kind of stats-oriented and dedicated people will argue, is that visualization or kind of graphic exploration of data is a good starting point. So, like, strictly speaking, you could run an evaluation and get all the data back and process it and do all of the stats and get the outcomes and never look at a graph or anything, and have a result. But for the most part, starting with a graph helps us kind of get an understanding of the data. In the same way I can describe a person to you, detail by detail, their hair color, their eye color, how tall they are, that kind of thing. It's much easier and maybe more intuitive to just see a picture of them. And so it can also, I should say, with data, help you quickly discover any problems in your data sets, whether that be inadvertent things that you did collecting the data, or just outlying responses. That's the graphing things is a good way to do that. And it will definitely kind of inspire you in terms of what other questions should you be asking, what areas should you explore, and you'll usually end up looking at making different graphics for the same data to try to understand things better. But I should warn you that as you make graphics, you can make graphics that mislead people and mislead yourself, which we'll talk about more in our next lecture on Thursday when we talk about visualization specifically. But in general, starting with a graphic exploration is a good way to go. So just as a simple example here, I've just pulled a couple of the response histograms for the mid-semester survey. So I pulled the category for lecture and the category for quizzes. And so if you notice, they both have an average of 4.61. But if you look at the distribution here, and these are just counts for each rating. So, the survey asks you to choose 1 through 5 on each of these, right? And so this is just how many people chose 5, how many people chose 4, represented as bars. you can see that there's difference here, even though the average is the same. And this is just a really, really basic way of looking at this, right? This is just, the pure histogram of the responses that came in on that survey. But there's meaning, perhaps not, but in this visualization that you get by seeing the distribution that you don't get just by seeing the average alone. Now, I could give you things like the standard deviation and maybe like some other values to help you create this. But in general, the graphical version does a good job of conveying it quickly. And I should say most data is not as simple as this, mid-semester survey with just 20-something responses, right, on a couple of these items. So starting with graphic exploration is a good way to go. What you kind of want to will naturally want to do is start to measure central tendency within your data set. And so kind of the most familiar measure of central tendency within a data set is taking the mean or the average of the data set. So just, if you've got 1 through 5 ratings, like we had in that survey, I've just taken and summed them all up and divided by the number of responses I had and got 4.61 in that case. And that represents the average of the responses there. In a similar way, you could use a median value, which just sorting everything, smallest to largest, and then going right to the middle and taking that value. It's really helpful when the distribution is skewed, right? So if you've got, if you look at the distribution of income I think in the United States, let's take for example, you've probably got some people at the high end, just really way up there, but there's not that many of them. And if you were to take an average, that may skew the overall average to not really be representative of kind of what most people are experiencing in terms of income. So the median can be useful when you've got those outliers on either side of a distribution. It can help fight that skew. Kind of in a similar way, mode, so the most frequently occurring value in a data set can be useful, especially if there's limited possibilities. So you can kind of count, what was the most frequent response that was given. So to go with our measures of central tendency, we also have measures of variability within a data set. So the range just being kind of the difference between the minimum and maximum values that you could possibly have. And the variance being the degree of spread in the data as it relates to the mean value. And I've got a description of how to compute that there, but this is basically telling you how much variation is there among your responses or your results for this thing that you're looking at. And related to that is a standard deviation, which is basically just the square root of the variance. Is medium a useful stat? It can be. It definitely can be. Off the top of my head, I can't think of it being kind of the default on anything easy, but definitely when you start to get into more complicated study designs, and you have to deal with data that's non-normal and doesn't adhere to different distributions, then you start to find different approaches that do things like trimming the distribution and looking at different values to compare them. So in general, like the things that we look at and that most things look at will be probably using a mean, and in some cases a median. But yeah, there's definitely a spot for every attribute that you can compute in terms of the data set. So the standard deviation just puts the variance in terms of the original unit. So Now that we've kind of talked about those two different measures that we look for in a data set, we want to talk about confidence intervals. So a lot of times what you want to do is estimate kind of a range of values that would include the true population value. So when we conduct a study or measure something or evaluate something, we only ask so many people, right? And it's just a sample of a bigger population. And what we want to do is try to estimate where the true population value lies. And we can't hit that dead on, but we can, with some confidence, express a range of values. And so a typical example is a 95% confidence interval. And so what we do is we use a combination of the number of people or evaluations that we have, the standard deviation within the data set, and kind of how confident we want to be, which we call the alpha level. And we can use that to compute a range, a confidence interval. And then we can compare confidence intervals to see if things are if we suspect within some degree of certainty that they're truly different or not. So if you've seen, a bar chart with the little error bars on the chart there. So if you look, let's see, here, kind of these little error bars here, those are showing you a confidence interval, basically. So this is a 90% confidence interval for this quick data set. And I should say all of these things you can compute pretty quickly, just like in Excel or Google Sheets or something. These are pretty basic things to compute and graph. And so those, if you see those bars, those are the confidence intervals kind of showing the error of measurement within each of these. And it again depends on what you've measured there. And that becomes important when we start to compare means. So if we, have people evaluate two different interfaces, we need to be able to say, is the evaluation of this one different than this one? And typically we do that with a statistical test of some sort, and there are a lot of them, depending on your data and your study design. And when we do these statistical tests, what we're really trying to do is explain variance. So roughly any kind of test statistic that we create is meant to represent how much variance we can explain by fitting a model to a data set, and divided by kind of how much is not explained by the model. Or you can think of it as effect over error. So you're kind of trying to get a signal out of noise. And so like I said, there's a lot of different test statistics for different scenarios. So if we're comparing two samples or two groups, right? There's the case where we could be looking at like one user evaluating two versions of a prototype. In that case, they would evaluate each of them. We would use a paired samples t-test because the measurements, come from the same person for each of the interfaces. Now, if it's more of a between subjects study where you have people who are just each evaluating a single interface, when you do that comparison, you would use an independent samples t-test. And as you might imagine, that's the case for when you're comparing two things. And I should say I'm introducing this term a t-test. It's just kind of one of the most basic statistical tests that you can conduct. There are plenty of things that will compute it for you, whether that be R or Excel or just some calculator on a website somewhere, or you can do it by hand if you'd like. But what this test does is gives us some probability that two data sets are truly different from each other. And so, as you can imagine, if you scale this up to where you're doing things like, more than two groups you're comparing, or maybe you're doing a between within design where people are seeing multiple things, but there are also higher level conditions, then then you can get into much more complicated territory. So if you start to do that, you get into doing ANOVAs and MANOVAs and all kinds of things that we won't care about too much for our simple cases, but are important for these designs of more complicated studies. And we'll look at some more concrete examples of doing statistical tests as we go. We'll probably look at a couple of them on Thursday along with visualizations. I don't know how much time. We've only got a few minutes left today, so we may not get that far. So the other thing I want to talk about is correlations. So most of us are pretty familiar with this in terms of you've got kind of like, in this case, this is a scatter plot showing amount spent on ads versus record sales. And you've kind of plotted all these points out there, and then in this case, we've mapped a linear line trying to fit that as best we can. You can fit all kinds of lines to these things, all kinds of models. But the idea is to see if one variable is correlated with another variable. So an example is like height and weight. Usually there's some correlation there. And we've all heard that correlation doesn't imply causation. And at a surface level, that just means that when two things are correlated, it doesn't necessarily mean that this one causes that one or that one causes this one, or really that either of them are actually that related. So you kind of have to test more specifically to get a causation finding. And you also have to watch out for third factors that you might not see that might be driving both variables, right? They might each be correlating with some other factor. So that's something to keep in mind. And then briefly, I'll mention non-parametric tests. So these are used to analyze some of that nominal and ordinal data. They don't make assumptions about how the values are distributed. So if you take a stats course, or if you're taking a stats course, you've probably spent some time talking about normal distributions. That's kind of the default assumption of a lot of parametric tests. Non-parametric tests don't make that assumption. They're based more on odds ratios and frequencies and counting. So one of the most common ones that you'll run into is the chi-square test. It's frequently used to compare counts or frequencies. So when we're analyzing data, we've got to remember all of the biases that exist at every level. So we've talked about a lot of those when we talked about the reflection today. Just a few more areas you might think about, and kind of always be on the lookout for any biases that might creep in at any level of analysis, including the way that you analyze data. One question that I kind of want to address here is, how many participants do you need in a study? So kind of the quick answer for a lot of designers, if they're just doing something informal, just kind of want to get an idea of like the basic usability feedback. Some say about 5 is okay-ish, and some say no, that's not enough. The truth is, it depends on the application and the specific domain. So you can see this graph showing the number of issues discovered as a result of the number of participants in a study, and you can see that it kind of levels off there. If you're conducting an actual study that you're wanting to generalize from and publish and use robustly, you're going to need a lot more than 5 people. You're going to need to do some formal analysis to find out exactly how many people you need given your assumptions and given the stats approach you're going to take. But when we're talking about just a quick usability study, somewhere between 5 and 10 independent people tends to be an okay-ish number for these basic things, for basic usability. So I did want to mention just a little bit more about scales, rating scales. in particular the Likert scales, the debate between having a neutral point or not having a neutral point. So if you have an odd number of choices, there will always be kind of a center ground, a middle ground for people. Whereas if you chose an even number of choices, you will force them to go one way or the other. They can't just take a neutral position. So you've got to weigh that when you design a scale rating. Does it make sense to have a neutral point? It's usually, I would say, you've got to make more of an argument if you're not going to have a neutral point as to why, because people can be quite neutral on things. So that's something to consider that's going to affect your analysis when you choose your scales. And we've talked a little bit about interval data and scale ratings and kind of the details there. So I think what I want to do is kind of put us on pause here, and I think we'll go ahead and incorporate this into Thursday's lecture, the rest of this, and we'll see some examples, and we'll do a little more hands-on with analyzing data, so we'll get more of a feel for it there. So you'll have a quiz that'll be due before class on Thursday. That'll be posted as soon as we're done here. It's a quick quiz about data types. Your project revision 1 is due Sunday by midnight, and homework 3 coming up a week from today by midnight. And then next week we'll have an exam out. You'll have a full week to complete. We'll discuss that later. I just indicated it here so that you know it's out there. No reflections for the next 2 weeks though, so don't worry about that. Okay. That's all I have. We will meet on WebEx on Thursday to continue with data visualization. If you have any questions, I will stick around for a few minutes if you want to just throw them in the chat. Otherwise, thanks, and have a good day.